Okay, the objective of this recording is to introduce compound inequalities, um, specifically focused on the representation of the solutions of compound inequalities on number lines and the reading of number lines with solution sets interpreting their values in appropriate notation. And so what we're talking about is something known as a compound inequality. A compound inequality can also be known as a combined inequality, and this consists of a compound inequality consists of two inequalities, and those inequalities will be joined by the word and or by the word or. And so, as is explained underneath, when the compound inequality is combined with the word and, what we're interested in is the intersection of the graphs of those inequalities. And so, in other words, what we're interested in is the overlap between the solution sets. We need the solution set to satisfy both of the inequalities before it can be considered a solution of the compound inequality. Okay, and then when we refer to a compound inequality which is joined with the word or, it is the union, or another word for that sometimes is sum, so it's the union of the graphs of the inequalities. And what happens in this instance is that there's no overlap necessary. Both of the solution sets are considered solution sets of the compound inequality. Okay, and so what I'm going to do at this point is demonstrate a series of examples which will model the skills that you need for this introduction, and following that you're going to be working on some practice problems. Okay, so first example requires that we graph the following compound inequalities on the given number line. And so in the first example 1a, we have the compound inequality minus 2 less than x less than or equal to 8. This is the equivalent of a compound inequality with the word and so what we're interested in is the portion of the number line that represents x greater than minus 2 and at the same time less than or equal to 8. And so in order to graph this, what we're going to do is move to 8, and we're going to put a closed dot because, as we can see from the inequality, the value 8 is included in the solution set. We are then going to move to negative 2, and in this case we are using an open dot because the number minus 2 is not included, and it is all numbers between those two, and so we're going to join those, and this represents the solution set of our compound or combined inequality. Okay, second example, what we have here again is a combined or compound inequality, once again with the word and. So we have from minus 3 less than x, which is less than or equal to 1. So once again, as we did in the first example, solid dot on the number 1 because it's included. We have an open dot on minus 3, and the solution set is all numbers between those two numbers but including 1. Okay, so in part C we have an instance where the compound or combined inequality is being given as two inequalities joined by the word or. Okay, so in this particular case what we're going to do is graph each of those inequalities separately, and since this is an inequality joined by the word or, it is irrelevant whether or not the solution sets, the individual solution sets, overlap or not. Okay, and so we have x greater than or equal to 3, and so our solid dot on 3, and we are going to the right hand side. We do need to put an arrow in this particular case because we are interested in all numbers larger than 3, and there's no restriction on that. And then for the second portion we have x less than 1, and so we have an open dot on the number 1, and this time, since it's less than, we are moving to the left hand side, and this is our solution set for the given combined inequality. And now what we see in D is actually the same problem as was given in part A and B, question 1A and B. And so what we can do is just show you how this could be written in an alternate form. We have x is less than 9 but not including, and at the same time it needs to be larger than or equal to 1. And so what we could do is say that x is larger than or equal to 1 and less than 9, and that would be an equivalent form of the compound inequality which is given in question 1D. Okay, and if we move to the graphing of that, it should then be relatively straightforward. This time we are starting on 1 using a solid dot going up to 9 but not including 9, and let me just use a slightly thinner marking for that, and so we are on 9 but not including 9, and we are joining those two all numbers in between 1 and 9 but not including 9. Okay, and so in example 2 what we have is a slightly a different question, ultimately the same, but what we're being asked to do in this question is to write an inequality given the solution set. And so what we can see here is that we have a starting value of -6 which is not included, and so we can say -6 is less than x. In this case, since we have values which are between -6 and 3, this is an example of an and compound inequality. We are only interested in the solution set between the given numbers, and so we are able to write x less than or equal to, as you can see from the closed dot, 3 in this case. And so an alternate way, of course, would be to write it as x greater than -6 and x less than or equal to 3. Okay, and finally, the final example is a translation question. And so what I mean by that is taking words and translating them into an inequality. And what we're interested in is all numbers less than 3, and once again we have a combined compound inequality joined by and at least -6. And so we need to understand that the words at least mean that the value is included. And so if they are at least 6, then we are starting at -6 and including -6. I'll use the variable x, and we want and, which is why I'm writing a combined inequality in the form that I am, and we want the numbers to be less than 3. 3 is not included in the solution set, and this is our translation of the phrase all numbers less than 3 and at least -6. Okay, at this point what you need to do is turn off your computer and move on to the next couple of pages of your note, where you will find some practice exercises similar to the ones that I've just modeled, and go ahead and complete those now, and then you'll be able to watch another video with the solution sets.